1, angles of polygons. So here we're going to be dealing with the different polygons and the angle measures on the inside and outside. So first, a triangle has 3 sides. We know that the angles in a triangle add to be 180 degrees. What about a quadrilateral? So since we know that a triangle adds to be 180 degrees, if I split this up into 2 triangles, then I can say 180 plus 180 would be 360. Okay, so then I can say that a quadrilateral would add to be 360 degrees. A pentagon, I split this up into 3 triangles, each with a sum of 180 degrees. So 180 times 3 is 540 degrees. And then same thing for a heptagon, split it up into triangles. Here, a 6-sided shape, I'm splitting it up into 4 triangles for a sum of 720 degrees. So the polygon interior angle sum theorem is the sum of the interior measures of an n-sided convex polygon. So this n part is just the number of sides that our polygon has, whether it's 6, 5, 4, whatever it is. We're splitting them up into triangles because we know a triangle, because we know that the angles in a triangle add to be 180 degrees. And we're taking the number of sides and we can split it up into 2 less polygons. So 4 sides went into 2 triangles, 5 sides went into 3 triangles, 6 sides went into 4 triangles. So it's always 2 less triangles than the number of sides that we have. And then we have some different names for our polygons. So a heptagon has 7 sides, octagon 8, nonagon 9, decagon 10, undecagon 11, dodecagon 12, and then after that we just name it by the number of sides. So a 13gon, 14gon, etc. A regular polygon has all congruent sides and all congruent angles. So this would be equilateral and equiangular. Okay, so a regular polygon, if I tell you that we have a regular heptagon, we know in that heptagon that all of our side lengths are going to be the same, and then all of our angle measures are going to be the same. So for number 1, a convex polygon has 13 sides. Find the sum of the measures of the interior angles. So again, we're going to take our equation here. If we're working with 13 sides, n would be 13, and then we would say 180 times 13 minus 2, or 180 times 11, which is 1,980 degrees. So the sum of the interior measures, the sum of the interior angles would add to be 1,980 degrees in a 13-sided polygon. All right, on this one, so the measure of an interior angle of a regular polygon is 120. So they're telling us that one inside angle of this polygon is 120 degrees. So I have to find the number of sides. To find the number of, or to find the total, 180 times n minus 2 is the total sum of all of the angles. If I know that one angle is 120, then I can multiply it by how many angles it has, Well, if it has n sides, it's going to have n angles. So here 180 times n minus 2 equals 120 times n to get the total number, or the total angle measure. So then just solving this, multiply this through 180 n minus 360 equals 120n. And again, just solving, I'm going to go ahead and bring this over. So negative 360 is equal to negative 60n. So our shape is going to have 6 sides. So in a 6-sided polygon, each angle on the inside measures 120 degrees. Example 3, find the value of x. So I might give you something like this, and you have to tell me what x would be. So first, we are dealing with a 1, 2, 3, 4, 5-sided polygon. So let's figure out the sum of a 5-sided polygon. We would use our trusty equation here, or 180 times 3, which is 540. So we know all of these angles have to add to be 540 degrees, so then I can add them up. So for D is 4x plus 5. C is 5x minus 5. B is 6x plus 10. A is 4x plus 10. And then E is 7x, and that needs to all equal 540. So let's go ahead and combine like terms. 4 plus 5 plus 6 plus 4 would give me 26x. Positive 5, negative 5, those cancel out, and I have 10. Oh, I forgot to add that in there. Plus 20 is equal to 540. And then just solve here. So 26x is equal to 520. And we would get x to be 20. Okay. Example 4, find the measure of an interior angle of a regular 18-gon. So we have to figure out what one inside angle would be in this 18-gon. So let's figure out the total first. The total. So n would be 15, or 18, I'm sorry. And then 180 times 18 minus 2 is 180 times 16, which is 2,880 degrees. This is the total of all angles added together. Here, they just want us to find one angle measure. Well, if I'm finding one angle measure, then I can go ahead and divide 2,880 by the number of sides that I have, because again, the number of sides has to be the same as the number of angles. So that would be 160 degrees. So that would be the measure of one angle on the inside of this regular 18-gon. All right, on the back, now we're working with exterior angles. So to find the sum of these exterior angles, let's look at some pictures real quick. So in a triangle adds to be 180 degrees. So I can say 180 minus 87 minus 43 would give me 50. So this angle right here is 50. And then these all make a linear pair. So I'm going to take 180 minus 87. That gives me 93. 180 minus 43, that would give me 137. And then 180 minus 50 is 130. If I add all of these up, 130 plus 137 plus 93, that would give me 360 degrees. Let's try this quadrilateral. So in this quadrilateral adds to be 360. So 360, and I'm going to subtract 60, subtract 95, subtract 125 to find my missing angle. That would give me 80. And then again, they all form a linear pair. So 180 minus 95 would give me 85. 180 minus 80 is 100. 180 minus 125 gives me this 55. And then 180 minus 60 is 120. So now I'm going to add all of these up. So 120 plus 85 plus 100 plus 55 gives me 360 degrees. Take a second and pause this video and you try this next shape. So this next one, they're telling me that all of these angles are 110. And then in this shape, our angle measures add to be 720 because we have 6 sides. So then this would be 140. So take a second and you fill the rest in to see what the sum is of this shape for the exterior angles. Okay, so you should have received that this angle was 70, this one was 40, 70, 70, 40, 70, which then if you add them all together, they equal 360 degrees. So that means the polygon exterior angle sum theorem says the sum of the exterior measures of an n-sided convex polygon is 360 degrees. Always. Doesn't matter it doesn't matter how many sides the shape has. In a convex polygon, the sum of the exterior angles will always be 360 degrees. So in example 1 here, find the sum of the measures of the exterior angles of a 27-gon. Well, I don't have to do any math. It's just 360 degrees. Okay, so in a 45-gon, the sum of the exterior angles is going to be 360 degrees. Find the measure of an exterior angle of a regular decagon. So a decagon has 10 sides here. So if I know that all of the angles add to be 360 degrees for the exterior, then I can divide it by the number of sides and say that each angle then should equal 36 degrees. Example 3, an exterior angle for a regular polygon is 14.4 degrees. What is the sum of the interior angles for this polygon? So first, I need to figure out how many sides it has. So to figure out how many sides, they're telling me an exterior angle is 14.4. Just like we did up here, we took 360 degrees divided by the number of sides, and that gave us this one exterior angle. So if I solve this really quick, I'm going to multiply by my denominator on both sides. That equals 1. So 360 is equal to 14.4 times n. Divide by 14.4. And n gives me 25. Okay, but I'm not finished because they're asking me the sum of the interior angles. To find the sum of the interior angles, we use 180 times n minus 2. Now I know that n is 25. So 180 times 25 minus 2 gives me 4,140 degrees for that polygon. Okay, so find the measure of an interior angle and an exterior angle for a regular dodecagon. Okay, so to find for the interior angle, let's find the sum of all of our interior angles. So to do that, 180 times dodecagon has 12 sides. So 180 times 12 minus 2 gives me 1800. And again, this is the total of all of my interior angles added together. To find one interior angle, you are taking that total and dividing by the number of sides we have. So each angle on the inside of my regular polygon then would be 150 degrees. To find my exterior angle, we know all of the angles in a polygon, the exterior angles add to be 360 degrees, and then I can divide it by the number of sides that I have. So that would be 30. And that's all.